In this video, I'm going to discuss the concept of containerisation, specifically using Docker containers. So, I know the screen looks a bit busy, but don't let it put you off. It's just here to demonstrate how we could do things, or how we do things if we don't use containers. So, looking at the same architecture that we've been looking at in the previous videos, we've got users with the user interface, which uses HTML, CSS, and JavaScript for the front end for the UI. And then the user will send requests to the back end, where there's another application running, and it will interact with the database to return whatever it is that this service is asking for, and it'll return the results back to the user. Also, the user interface is stored on here as well. The HTML, CSS, and JavaScript files are stored on here. And so when the user accesses the particular website, jokes.com or whatever it is, that request goes in, and the three files, the HTML, the CSS, and the JavaScript, will be returned to the user for the front end, and then the user will interact using that front end to send instructions to the program that's running on the back end. The reason for storing the front end files on the server are so that this person can also get those front end files and get their user interface. This person here, which could be in a different country, can also get it. The reason I put a dotted line in for this one is because I'm calling this user administrator, and so they've got special access. We don't want users being able to directly access the database, because that's where all the good stuff is. We don't want to expose that to just any old person. We allow them to connect to this application that's running in here, and it will access the database on their behalf. Whereas an administrator may need to log in to do administrative tasks like upgrading the operating system, for example, or installing software in the first place, or configuring and initializing the database. So they've got a special connection, which is a secure connection. That's why I've shown it as dotted line. Okay, so what I'm saying down here is that if we are going to install applications on the server, or the back end in the remote destination, in the same way that we've installed them on our local machine. In other words, we've got all our application files. We're going to need to install Node.js, because that's what our applications need to run on. Okay, so we need to install Node.js on here, and we'd need to install MySQL Server, the relational database management system, to manage our database with all our jokes in. And we might need to install other stuff as well if the program was a bit more complicated. So it's quite a lot to do here. So just to illustrate, this is an example of installing Node. So you'll see there's quite a lot of files that get downloaded and installed onto the operating system in here. And then we've got to install MySQL as well. And so there's a lot more files get downloaded here as well. And they all get integrated into the operating system. And then we've got to somehow get all of our application files, and they're going to have to be copied onto here as well. Then we need the administrator to be able to log in and create the tables in the database, and then populate the tables with all the data. So it's quite a lot to do, really. But it's perfectly reasonable. There, that's been installed, so we could run our program on this server now on Node.js, interacting with this database, which is the MySQL Server database. Now then, a downside of this, there are a few, is that if we needed to rebuild this virtual machine, in other words, it became unstable, or we needed to change it for a different type, and we deleted it, then we'd have to install all this stuff again. If, for example, we installed several programs and we wanted to remove one, then we'd have to uninstall it, and that can be quite lengthy. Well, we need the database to be populated, and modern enterprise systems tend to use containers. So containers is a bit of a more simplified approach to doing all this stuff. Okay, so what are they? All right, so I tried to create this analogy whereby if we say you put a plant in the ground, we'll call the operating system as the holding place or the destination of these files, and the files themselves call the plant the application, and these are all the files associated with the application. So there's loads of them, which you've just seen. If I'd installed the files directly into the operating system, there's lots of them. Then install another program, and it's got lots of files as well, and they're all going into the operating system. And in some circumstances, they can even, they shouldn't do, but they can interact with each other, depending on, where you've got this program from, where you've got this one from, how good it is, how well it's been written. And they're quite deeply embedded in the operating system. Now, if we look at containers instead, then we can say, okay, well, we'll install our files, all our files, so the roots of this plant will all be in here, but inside a container. So when we install another program in this container, as in this case a plant pot, all its roots are in here, and they're completely separate from each other. So one can't affect the other. If this plant gets diseased or is ill, in other words, your program gets infected with a virus, or your application is just not well written and it starts doing weird stuff, it could start infecting this by corrupting some of the files that it's next to. It's possible. Whereas these are completely independent of each other. You may be a hacker, you might be trying to use this program to try and get through to access this program. There's no real significant barrier to doing that. Whereas these are all completely independent of each other. Now, you think, oh, I like that coloured flower, I like that coloured flower, I don't like this one, it's like a cabbage, I don't really like that in my garden. So, in this case, you'd have to dig the plant up. So you dig it up, and you could very likely affect this one while you're doing it. You might end up impacting some of the files on this one. Could do, depends how well the application's been written and how well the uninstallation program's been written. But you probably, like me, found that when you try to uninstall things from Windows or Linux, then it can sometimes affect other programs, or it can even leave bits of itself behind. With this approach, we think, oh, we wanted more colourful flower in there. We'll get rid of this one. We don't need to uninstall it. We can just delete it. Gone. Without impacting these, because it was self-contained, completely isolated. And then we just create a new container, a new pot, and put our program in there. So that's the key principle behind this. It's flexible, they're isolated, and we can delete them and create new ones very quickly. All right, so let's have a look how that works then. So we've got the physical machine. The physical machine is it's like the physical machine I showed you in the previous video. It's a computer, quite a powerful computer in a data center somewhere. This physical machine could be a laptop. You can put virtual machines on a laptop. I'm talking about the ones in the data center, in the cloud. So physical machine, very powerful machine. We're not going to use the whole machine, so we're going to divvy it up into virtual machines. So here, this big blue square here is our virtual machine. And here, just to show you that you can have other virtual machines on the same physical machine, that's just somebody else's machine. We're in a public cloud. So somebody else could have created virtual machines on the same physical machine, as was explained in the previous video. Okay, so on this machine, then, we could have whatever operating system we want on the virtual machine, because it is just a computer. Somebody else can have whatever operating system they want on their computer. Virtual machines are isolated from each other. Right, now on the virtual machine, we're going to install some programs if you want to. Now, the operating system will have some programs already pre-installed, like if it's the Windows, like Notepad, and then you might install Word or whatever onto the back end, or whatever it is. Might not make sense to install Word on a remote machine, but you get the idea. You can install whatever you want in a similar way I just showed you in the previous slide. But I'm not going to install anything. I'm not going to install any of this stuff on the server because I don't need it. I'm going to use containers. Now, to use containers, we need to install one program, not loads of programs, just one, and that is Docker. So Docker is a program that we install, and I'm showing it's installed into the operating system by showing it sort of in the operating system like this. And so these files will be installed in the operating system like I showed you on the previous slide. In other words, like this. So we want as few of those as possible. I'm only going to put one in, so there's only one in there. There's nothing for it to be affected by. That's this one. I need this one installed because I need Docker to be able to create the containers in the first place and run them. So it's the thing that's going to be responsible for that. Okay, so I'm saying here, we need Docker installed to create an image and then run it as a container. So what's an image and what's a container? So I'll get onto that. Well, an image is like a zip file where you take a lot of files and squash them all into one file, and then you can just manage that one file. And I'll show you a demo of that in a minute and show you what the file looks like. So rather than having hundreds and hundreds of files to have to copy around, we just have one for and then what we can do is when we run that file, then we create it in a container. So these are containers here. So we copied one file here onto the operating system, not installed it, just copied it across, and then told Docker to start it as a container. And then here we've copied in another image and told Docker to start as a container. So these applications are running in here in isolation of this one running in here. Okay, so what we can do is we can create our software on the local machine, for example, if that's what you want to do. So we can write the code on the laptop, test it on the laptop. You can create containers on the laptop without any problem, and then we just deploy it to this remote machine and tell Docker to start it and run it as a container, and that's that. So we're going to create a Docker image, like I say, which is like a zip file, and then from that image we're going to contain a container in which the program will run. The analogy here is a bit like if you install applications on the operating system, then they're all sharing resources within the operating system. They're all quite closely aligned near each other. And so this is a bit like a room in a shared house where you've got a level of independence, right? I mean, these are separately installed, but you're sharing a kitchen and you're sharing a bathroom. And then if somebody in the kitchen makes a mess, aka it's one of these applications makes a mess, your application may be affected by it. In other words, you can't go and make your own tea before you can clean up somebody else's mess, for example. Containers are more isolated. They're more like a self-contained flat. They've got everything inside the container they need to run the application. So all the program is in there. All the program dependencies are in there. I'll talk about dependencies in a minute. Everything you need to run this program is in that little box. So that's more like a flat where you've got your own kitchen and your own bathroom, and nobody, you don't need to see anybody. You can just you can live there, no problem. And this person, likewise. It's same with these. There's no sharing of anything really substantial. Now I know, there's a little bit more to it than that, but fundamentally, think of it like that. All right, so this is the analogy similar to the first slide, where I'm going to show you that I'm not going to install much this time. Now what I do have to install Docker. All right, so this is Docker being installed. So there are a few files that get installed, but I'm only going to do that once. I'm only going to do that for one installation. No other files going to get installed, because I'm going to take my application, or the jokes application we've been working on in this series, and I'm going to create an image of all the files in that application. In other words, squash them all into what's like a zip file, so it's just one file. And then I'm going to copy them onto the remote machine and then tell Docker to start them as a container and run the program. And similarly, I'm going to get the database, which you saw on the previous slide. It's got hundreds of files in it as well. I'm not going to bother with that. I'm going to simply get an image that somebody else has created, made available on Docker Hub. And I'm simply going to download that image onto here and tell Docker to start it as a container. And then I've got a fully functional relational database system running without installing anything. Okay, so what I'm going to do, I'll do a demo to show this in action, installing Docker and then pulling these images down and then running the program. Okay, so this is the deployment process and the build process. So what I do is I've got a laptop. I write a little file that's going to provide Docker with the instructions of what it is I want to build. And it'll say, yeah, okay, as long as all the files are available, I'll squash them all into this image. So it creates an image. So there's all our jokes code in there. And we're going to squash Node.js in there as well, because we need that. So we're going to squash the whole lot into one file. And then we're going to tell Docker to start a container using this file. And so it runs a container. Our program will run in there. There's like a little doorway that we can get access to it through the network. And so we can send information into it. It'll do the processing, then it'll send the response back out again. So once we're happy that that works, then we would create a one-off called a Docker, called a container registry. Basically, it's just a website somewhere that's hosted by someone. And we can just push our images up to that website. So Docker Hub, you can create an account on Docker Hub, and it literally is just a space somewhere, a bit like when you push your photographs up to the cloud. You think, well, they've gone somewhere, and I know that I can get them back again. Well, it's a similar thing with this. You're going to push this image somewhere. It's here on the cloud. And so that not only saves it from your laptop, in case your laptop breaks, you see your images up here, but also it means that because it's on the internet, other people can get access to it as well if you want them to. You don't have to. You can set constraints around who can access it, or you can let anybody have access to it. You can use Docker Hub, which you literally go online and say, I want an account, Docker Hub, yeah, no problem, it's free. You can create a registry within Azure. AWS have similar functionality as well, but you're going to pay for these. So I'm going to use this one, El Cheapo. Okay, so our image will be stored there. We're going to create a virtual machine because obviously we need one to be able to run this thing at the back end. Once we've created this virtual machine, we're going to install Docker. I could just explain because we need Docker on here for it to be able to create and run the containers. But once Docker's installed, that's the only thing I'm going to install into this operating system, in which this case I'll put a Linux operating system on it. But that gets added, that gets created when we create the virtual machine, as I've shown in a previous video. All right, so once we get this running and we can log into it as an administrator, we can just say, give me your image, give me your jokes image. It'll download. All right, I've got the image. Right, Docker, start it, and it'll run. That's it. And similarly, we wanted well, the database. Well, I haven't got a MySQL database. I haven't written that. I haven't created an image of that. Somebody else has. And they make it available on Docker Hub for people to use because it's a very popular thing to do. And there's Mongo database. It's very popular. There's an image of that on Docker Hub as well. There's thousands of them. So if there's an image on here already created, there's a value to you. Then we can just say to Docker, go to Docker Hub, get me the image, download it. Okay, now start it a container. And then you've got a running database. So that makes life so much easier. So I'll just do this demo of showing you how to do this, to go through this process. So create an image, create a container, test it. If it works, push the image up to here, create a VM, install Docker, pull the image down, start it as a container, and then we can run it in the cloud. All right, let's see how we can get on with this. So here's the application we've been looking at for a while. Look at all the files in here. Then there's not many because it's only a little demo, but you can imagine a proper application would have hundreds of files in here. But just show that there are files in here that you would recognize. So in this public folder here, we've got CSS, HTML, JavaScript. So HTML, you'll see you'll be familiar with. Here is the usual stuff. There's a head section. The head section is asking for the CSS file and the JavaScript file to build our front end. We've got a heading here that says Joke Central. So when I run this thing, you'll see that comes up as a title. And so you're quite familiar with this stuff. Got a CSS somewhere here. And this is just responsible for coloring stuff in. So the heading that says Joke Central is going to be in white. The background, the whole body background is going to be in black. And we're going to center the text. So this is stuff that, again, you're familiar with. Okay, here's the application that's going to run at the back end. All right, we haven't looked at this, but there's a program going to run at the back end. And all it's going to do is, you can see, I can make an API call. That's what this is going to do, called types. And it's going to query the database and say, give me all the different types of jokes you've got. So database returns them, and then we send these back to the user interface, and it can put these types in a drop-down box, and so the user can choose what type of joke they want. And here's another API endpoint where we go /jokes and then add the type. What type of joke do you want? So to call this API, we simply say /jokes /dad, and it'll return dad jokes. How many do you want? Or we can send how many we want across, and it'll send that many jokes back. By default, it'll send one. All right, so that's about all you need to know about this code here. Now, this bit here is returning the web pages when the browser asks for them. Okay. Right. So that's that. We could run this inside the Visual Studio Code here to test it locally. I'll do that then. I think I've got a database installed. Let's give it a go. Okay, so we've got a server listing on port 3000, and it's connected to a jokes database. So that's good. It's looking promising. So if I go to a web browser, then localhost, that means my laptop, port 3000. There we are. Now you see joke central is in white. The whole thing is background is black. It's made the API call out to pull the types of jokes back. I picked add jokes. I only want one. Then when I make the next API call by pressing that button, it'll ask the back end, in which case the back end is still on our laptop. We're simulating the back end, and it'll request a add joke. Why don't text tell jokes? Because they would crack each other up. Okay. Well, it's nearly Christmas, so I suppose these are probably apt. Anyway, we know that our application works now. So inside here, we're good to go. All right, so that's that tested. So that's our development environment. We can debug it and everything, get it all working in there first. All right, then once that's been done, then what we can do is we can create an image. What that image will do is a Docker image. I'm going to say all these files. All right, so there's all these files. All these files are going to be put into the image. All this, we need all this stuff to run that program. What these are all dependencies. All right, our program depends on this stuff to work. Here's some cookie handling code. Here's some more stuff. All right, so this is all going to get squashed into a single file, and we're going to squash in the whole of Node.js into that single file as well. All right, so lots of stuff, but we only have one file. Makes life easier for us. All right, so if I say, oh, I need to run Docker first. Need to start Docker. So I'll just pause the video while Docker starts up. So I have to go onto this page to. Okay, it started now. Docker is running. So now I should be able to run Docker commands. Just check it out. Okay, let's ask it for a version number. That sort of tells it it's alive. All right. So what I'll do is, you've seen all these files. We don't need to see these now. Let's make the screen a bit bigger. And I'll make this a bit bigger so you can see what I'm typing in. So I'll just tidy this up a bit. Right. So I want to build the image. Oops. So build. It knows where my files are because I'm in the same directory as those files. And there's a little bit more to it than that. But anyway, I want it to build those files into an image. And I want it to download the Node.js as well. Here you can see it's downloading it from Docker.io. It's downloading that, and it's going to then build my files into it as well. And here we've got it built. So we've now got an image. I should have shown you there were no images there before, but let's have a look what we've got. How many Docker images have we got? Just one. The one that was created, well, it says 3 days ago. But I just created it now. There's a reason for it saying that. So some bits of it will have been around from 3 days ago. But anyway, in fact, what I'll do is, I was going to delete it and then show you again, but you'll have to believe me. So here's now the reason I've got this old Git Docker thing in front of my joke image is because that's my username on Docker Hub. And so when I push this to Docker Hub, it needs to know where to go. So there's the username, that's my repository name, / and within there I want it to be called joke. So that image, you can see it's reasonably big, 234 megs, but it's got all my files in it. All of those files that I showed you a minute ago, and the whole of Node.js. So, right, great. Let's see if it works. So I've got an image. So I'm saying to Docker, now you've got that image there, start it in a container. Right, so it's pulling the database now because it knows that I need a database for this. So it's pulling down MySQL Server from Docker. Now it's quite a big program, so it's pulling that down. And then we'll have the image of MySQL Server as well. So I'll have two images then. And it's going to start both of those images up for me once it's pulled them down. I could pause the video, but it's not going to take that long. I hope. We need 277.5 megs and it's up to 215. It's not far off now. And then what it will try and do is, once it's pulled that image down, it'll try and start my image that I just created a minute ago, and it will try and start this one as well. So I'll end up with two containers, as long as it works. So it says it's more or less done there. It's just doing a bit of final tidying up this last bit. Perhaps I should have stopped the video. Okay, so it's extracting this final part here. So nearly done here. Now once it's done, that seems to take a long time, but it'll only do that once because we've got the image then. Just took a while to download that one image. So now it's going to create, I don't worry what the volume and network is, but it's going to create the joke container. It's created the MySQL container. It's now creating the database. That's why we're waiting. It's configuring itself. And it's importing all our jokes into the database, having created the tables and such. So we just have to wait for it to do that. And again, once it's done this once, then it's very quick. Okay, so it started our database and it says the database is healthy. And it's now started our joke container. So what we've got now, Docker images, we've now got two images. There's the one that's got my code in it. And you can see it says this was created 4 weeks ago. This is from Docker Hub. Somebody's created this for us, and we just downloaded it, this image. We're going to run it as a container. So I have to look at what containers we've got. Docker PS is how you ask it to show us all the containers. So we've got two containers here that are running. We've got one called joke, which is my program running in its container, and we've got MySQL, which is the relational database is running in its container, and these two will interact with each other through a network. So it's a controlled interaction. So they're running, so it should work. Now what port number is this listening on? It says here it's listening on port 80. All right, in other words, the default port, so I don't need to type a port number in for this one. I can do, but you don't have to. So I can just say, I don't have to type in, this is the port number here. I don't need to type that in on this current one because the default is port 80 if we're using HTTP. All right, so localhost. I don't need a port number. And there we are. That is it running in our container. I could have put 80 on there to show you there's no jiggery pokery going on. We don't want HTTPS. Localhost 80. Okay. Just saves you an extra couple of keystrokes. And just to show you, if I put any other port number in, like 81, then it won't work. All right, it's got to be on the port that it's listening, that it's been configured to work with. Right, so we can see that our container works on our local machine. If we want more than one joke, we can get more than one joke. Now we're happy that it's working. then what we've got is, we've done this. I've created the image and I've run it in a container. So I can delete that container now, I don't need it anymore. I know it works. And so I want to make this available on the remote machine. That's where we want it, because that's where so everyone else can get access to it. All right, so I can stop that container. I don't have to, but there's no point in leaving it running. So I'll stop them, and then what I'll do is I'll need to push the image onto Docker Hub. So I need to log in to my Docker Hub account. Docker, and it's exactly what you would expect. It's just Docker login -u to say username. There's my username, like I explained a minute ago, and it must be password. So now I've logged in. When I'm talking about logging in, I'm talking about I'm logging into here. So that once I'm logged in, I can push that image and store it in my repository on the cloud, on Docker Hub. When I say the cloud is just somewhere else that's accessible via the internet. So this is hosted on the cloud. This will be, if I had one of these, this is hosted on the cloud as well. The cloud just literally means somewhere not on my machine that other people can get access to as well as me, if I give them the permission. Okay, so, and to push the image to Docker Hub is really, it does what it says on the tin. Docker push image name, which is all Git Docker. I can't remember if it's joke or jokes. You better check. What did I call it? Joke. Okay, so Docker push all Git Docker joke, not jokes. It looks like I'm putting jokes on there, but I'm not doing. Right, so it's going to send it up a few bits at a time just to enable it to do it in parallel. It's just a bit quicker. So it looks like it's pushing it as separate files, but it isn't. It's just one file. And I can check that. I should have had a look first, really, but I can check that out if I go to Docker Hub. Docker Hub login. Sign in. So get started is just where you just go in and create yourself a directory. Right, it's sign me in as all Git Docker. So if I want to look at my repositories, then all I need to do so here are the repositories. In other words, the images that have been uploaded. There's only one. I haven't got any others. That's the only one I've got. So it's been stored up there in Docker Hub. So I can access that now. Showing you it's there. So in other words, my image, this image now is sat in here, waiting to be accessed. Right, so I need to create a virtual machine. So if I go to Azure, we'll do it in Azure. I've not got Azure open, so let's log into Azure. Now I have created a virtual machine just to make things a bit quicker, because I've already shown you how to create a virtual machine. So if I go into virtual machines and have a look, see if it's running. I called it junk, and it says it's running. Right, so and that's its IP address there. So I'll just copy that. I'm going to need that. So I want to close this bit down now. I want to log into that machine. So I just happen to be working in this environment, but I'm going to log into that machine from the terminal here. So again, I'll make it a bit bigger for you to see what's going on. But what I'm going to do is, we don't need this bit here. I'm going to say, oh, let me just put this back. I'm going to say, I want to have access to my local machine here for typing stuff in, like Docker and such, like I just did. See, there's various commands that I've typed in previously. And I'm going to have another one of these so I can access the remote machine. So just to make it so you can tell which one I'm working with, I'll give them a name. So I'll call this one remote. And that's where I'm going to type in remote commands. So if I'm in this one, then I'm interacting with the virtual machine. If I'm on this one, I'll call this one local. So if I type stuff in here, when we're in this local shell, as it's called, or this local terminal, then you know that I'm working on these files on my laptop. Right. So I'm going to go on here on the remote. Now I'm going to log into that remote machine. That's a bit, it's a bit bigger than you can see. You don't need to see all this stuff here now. Alright, so SSH. SSH is secure shell. This is the, do you remember further back here? This is me logging in with these dotted lines. SSH allows me, that's going to create this secure connection for me. It's called secure shell. Secure shell protocol. So I'm going to log in with SSH secure shell. I've got a private key. In other words, a secret key. This is my secret. It's almost like saying that this is my, basically this is my password, but in a encrypted form. And so I'm going to pass my password effectively. I need to say what's the administrator's name? That's me. And where is it? Well, it's at the IP address, the one I just copied from Azure. So log into that machine. Okay, so it's logged in. Put a load of stuff on the screen. I'll clear that up. So I'm now logged in to the virtual machine. So I'm now in here. So when I'm typing in the remote section, I'm interacting with this computer. But in the local section, I'm interacting with this computer. Okay, so there's remote, and here's the local one. I can type stuff in here into the local machine. All right, so I'm on the remote machine now. Now I've already installed Docker to save you the pain of having to watch that being installed. It takes probably 2 minutes. Let's check it's in there. Type in, nothing's happening. Okay, we've got version 28 installed. All right, so what I can do is I can say I want the image of my jokes application. Let's see what images we've got at the moment. I'm hoping I haven't got any. No, there's nothing there. Containers running. Oh, no containers running, no images. It's a clean machine, this one. Right, so Docker, I want you to, you're just going to push up to Docker Hub, up to the cloud effectively. Now I want to pull it down onto my remote machine. So Docker, the opposite of push is pull. What do I want to pull? I may have to, no, I don't think I have to log into my Docker for this. I'll put it in as a public repository, so I should be able to pull this without logging in. I'll git Docker / joke. Right, There we are. So it's pulling that down in a similar way that it pushed it up from the local machine. So this is pulling this down to my virtual machine, which is deployed in London. And then we got it. So if I look at images, we've got that one image there. It's one file. There's hundreds of files in here, but we don't need to deal with that one file. Now, I need a database as well. So I haven't created a database, but somebody else has. And they've stored it on Docker Hub. So I can just say pull. And somebody's kindly created an image of the relational database, MySQL server. And thank you very much. I'll have one of them. That'll save me a lot of trouble trying to create an image of that. It's already there. And if I wanted MongoDB, I could have just said pull MongoDB. If I wanted other stuff, there's all sorts of stuff up on Docker Hub that people have kindly created and donated. Some of them you have to pay for, but there's an awful lot of ones that you don't. That's a bit bigger because it's a full-blown enterprise scale relational database. All right, let's have a look what we've got now then. Docker images. I've now got two images. There's my joke. There's the database. So with those, I should be able to run them. So it's trying to start the database, but it's going to have to configure it first. This database didn't get any jokes for it, so we have to install those jokes. It's built them, started them, says it's running. So let's have a look. So this time I'm going to not use localhost. I'm going to try and access it from this IP address. There we are. It's running on the destination machine. Why is 7 bigger than 9? Because 7, 8, 9. Yeah, okay. Right. All right. Working like a treat. So that's it. That's how we can simplify things using Docker containers. And that's the deployment process. And that's what engineers do. Now they would automate that process a bit. So instead of me typing push and pull and all that sort of stuff, we would do that. We would automate that. But that's the subject of a different session when we talk about CI/CD pipelines. What's next then? Oh, Kubernetes. You probably heard the term Kubernetes when people have been discussing things with you. So I'm going to talk very briefly about it. It's quite a complicated area, this, so I'm only going to talk about it very briefly. All right. What it is a container orchestrator. So it depends on Docker containers, or other suppliers are available, but Docker is by far the most popular approach. So it's an orchestrator. It can manage containers for us. If we start getting quite a few containers, there's a lot of typing involved. If you got, I only had 2 containers there. What about I've got 200? That gets a bit more difficult to manage. So we can use Kubernetes to try and manage these things. So we've got a user here connected to a back end. If traffic increases, so I've only been using this as one user, so it's only me. But you might have other people can access this website and use your jokes. So I think that's a great site, this. I'm going to log on as well. I'm going to tell my mates about it. And you get more and more traffic hitting your application. You're having to deal with all these different people. They could all be asking for a joke at the same time. And so you're going to start feeding the load of all these people making requests on you. A bit like being at work. And so if that happens, then we can ask Kubernetes to create another container of the same application and make that available. So the number of requests can then be shared between those 2 containers. And so they're taking only half the load each. It's a bit like you go to the supermarket and there's a queue and you've got one person on the till and they're not very fast. You think, oh dear, I'm going to get a beer. And then you think, oh, thank goodness for that. Somebody shouted, attendant on till number 2, please. And so the attendant goes on there, and then half the queue quickly jumps over to that till. And so we've now split the load so that there's each person's only got half the size of the queue. And if they're still struggling with that, then they would call somebody else out, and then we would spread some of the load onto the third checkout. Similar thing, Kubernetes can do that. So they're the person that's shouting, oh, help needed on till number 3. And it will create till number 3 for us. Now, once that traffic's died down and those people are not waiting, then we don't want 3 people sat on the checkout doing nothing. They could be doing something else. And so we'll close checkout number 3 down, and that person will go off and do something different. That's the same thing we can do with containers. If we created 3 containers, so like checkout 1, 2, and 3, we don't need that many now. Kubernetes can just delete one, because we can soon easily recreate containers. You've just seen it, and it takes seconds. If one fails, then it will delete and create a new one. So in other words, if somebody at till number 2 keels over or gets ill, then we don't necessarily delete them, but we replace them with somebody else. With containers, we will delete one and create a new one to replace it. And also, Kubernetes can handle upgrading the applications without having to have any downtime. So normally, if we wanted to update our application in here, we'd have to stop the application and delete the container, and then create a new image and push the new image, and then restart with the container. So there'll be a period of time when the service is unavailable, but we don't want that. So Kubernetes can manage to roll out an upgrade or an update to your application with no downtime. So let's see how this works. So if we've got application 1, like our jokes application, in an image, so this is a Docker image, I'm going to start off with that. So we're going to take that image and use Docker to create a container, exactly like I just did a minute ago. And that container is now accessible by the users. Right? So the users will interact with that container, and they will get their jokes. Or if it's an online shopping site, they're going to be getting, they're going to be able to order stuff through this site. All right, and then think, oh, this is a great site. There's lots of people are joining. So let's say we've got 50 users now. I think, oh, no, I can't cope with I can't cope with 50 users. I'm going to have to set a rule in Kubernetes to say, if we get more than so many users, or we could set a rule to say that if this container starts to struggle with the CPU that it's using, or if it starts to run out of memory, the amount of RAM that we're giving it, check all these things. And if we're getting close to max, and we're going to kill this application because it can't cope anymore, then we can detect that, or Kubernetes can detect that, and it will use the same image. We'll have to create a new one. We've still got one here. It'll create another container with the same program in it and make that available. And so these more users that are coming in, every time a user makes a request, it's going to go to here. The next person is going to go to there. The next one that comes in is going to go to here. The next one that comes in is going to go to there. So it's sharing the load. So we can take all these more users. We get more users. Then you might have to create another container to spread the load even more. And as many containers as you want, or as you need. Right. So say we update the application. Well, that image is no good to us now. We're going to have to create a new one with the new application in it. You might only change the color of the front screen or something, but whatever it is, if you've changed it, you've got to create a new image, push that image. There it is. We're going to pull the image down from Docker Hub. Here's our new version 2. Version 1 is still running in these containers. People are still using them. We've got version 2 here. We need to get version 2 into here without stopping the service. We don't want any downtime. It's a resilient service. Right, so what we're going to do is we're going to tell, or Kubernetes will tell Docker, create another container effectively. There's a bit more to it than this, but this is fundamentally what's going on. It's going to create another container. It's not actually, well, all right, I'll not get into it. Create another container. So we've got another container here now with the new program running in it. This is version 2 here. And we're going to divert some traffic to here. So we've now got some people are going to get directed to version 2. Other people are still on version 1. So we've had no downtime, but a few people are getting access to the new version of the application, but not everybody. And then Kubernetes will delete that container now because we don't need it. And so we're still back to 3 containers, but these people are seeing version 2. These people are seeing version 1, but they're still seeing something. They're still able to access the service. And then Kubernetes will create another container here and then start directing users to this container. And then when the users using this one, when they finish doing what they're doing, it won't allow any more users in here. Just wait for these to finish up and then close that one, delete it. So we've now got people on version 2 and just a few of them on version 1. And of course we do the same thing with this. And then they're all switched over to version 2 of the application. So there's no downtime. Now it looked like it was a slow process because I was just clicking, pressing the mouse button. But this happens much quicker in the real world. Okay, so what's next then? Key takeaways then. The application can be installed on a remote machine by installing all the files into the operating system. But if we did that, and that is like the initial, this is not using containers, then if traffic increased, we would find it quite difficult to scale that application because we haven't got containers to create to divert people onto. So containers give us this flexibility of being able to scale the application. If traffic decreases, we need to start only installing applications. It's not really sustainable using this non-container approach. It's possible, but it's not the best policy. It's time-consuming, error-prone. Each application are isolated. The container image, though, holds all the files for the application in a single file, like a zip file. And the deployment process is create the image using Docker on a local machine, push it to a repository like Docker Hub, and then log onto the remote machine and pull it from the repository to the remote machine and run it. That's a very simple process. You're only copying one file, and then Docker can create a container from it. So that's simpler to manage. I'm having to think, oh, I've got all the files. Have I missed any out? Human error can come in if you forget to copy one file. Well, if you've only got one file, you're not going to forget to copy that. Then if you want to scale a system up and you want to use Kubernetes to manage these containers, then some of the things it can do are, it can do quite a lot of things, but one of the key things is that if traffic increases to the point where we think we might struggle, then it can create another container to share the load. So we share it between the containers. You can have as many containers as that virtual machine can cope with before you actually kill the virtual machine itself. And if we do get to the point where the virtual machine itself is getting maxed out, because say, for example, we've got a virtual machine that can handle 10 containers, and Kubernetes wants to create an 11th one, then it'll create another virtual machine and start deploying containers onto that one. So then if traffic decreases, we can delete a container if you don't need it. And if Kubernetes has created another virtual machine to deploy containers on that because one virtual machine wasn't enough, then as it starts deleting containers, if you've got a virtual machine that's got none on it, we can just delete the machine as well. So we're not paying for it anymore. So it's all very flexible. It's called horizontal scaling, and it's also referred to as elastic scaling because Horizontal scaling is where you can make it bigger by adding more of the same. But what makes it elastic is that you can actually shrink it back in again as well. If you don't need as many resources, then you can start deleting them. So it's elastic, so it's more cost effective because you're not paying for stuff if you're not using it. If a container fails, because they do sometimes, programs crash, might run out of memory or whatever reason, then Kubernetes can detect that. It'll delete it and create a new one. So the system is self-healing. So if it does, you might have 10 containers. If one fails, then obviously the others are going to take a bit more of the strain. So Kubernetes will quickly create another one to take the load and delete the failed one. And if you want to update the application, deploy a new image, Kubernetes will create new containers, move people across to them, and then delete the old ones in an ordered manner. So there's no downtime. So it's a very resilient approach to enterprise systems. And that's that. So I hope that was of value.